So hello everyone, today my project topic is to realize mask learning recognition on Arduino. My project goal is on the Arduino platform, achieve the identification of weather-warning masks. Specific inspiration is derived from the new COVID-19 epidemic situations, where existing vaccines go out with masks is still necessary, but not all the people wear masks. I want to make a mask recognition machine and be able to use it anytime and anywhere by cameras. So this is my project outline, and this is my project structure. The basic research process is divided into determinate research purpose, collection of dataset, build model architecture, and training model, model transformation and transplantation, recognition of Arduino operation, and output of results and adjustment of model parameters. So in the process of research, I used Arduino Nano and Arduino in the hardware part, Google Cloud, Call of Notebooks, and Edge Impulse platform in the software part, and designed the neural network model, meaning based on TensorFlow 2.0. In the program, referring to the example of the cat and dog fight. The dataset for mask recognition this time is mainly derived from the GitHub case and the data of cargo. The general information of the dataset is shown here. After obtaining the dataset, I did the following work. Classified the picture dataset. I divided it into mask and no mask. Renumbered it and reordered the dataset and divided it into training set and the test set in proportion. Before being used as model input, it is necessary to reshape them into 96 multiple 96 size and grayscale them. Considering that the instance of mask recognition is image boundary classification, the architecture of CNN was selected with reference to the case of cat and dog fight, and the model training was conducted according to the dataset. The model architecture is shown here. The input parameter of the model is grayscale images. The model architecture consists of 2 layers of convolution, 2 layers of max pooling, 2 layers of full connection, and 1 layer of lighten. So the parameter selection of the model is shown here. The training result is here, with 35 rounds of training cycle. And also the confusion matrix here is kind of good. The accuracy is good, but the loss function is relatively large for the time being. However, considering the size of the model, the parameters are not further increased for the time being. And the model file is shown here. Simply select a file that is quantifies the integer 8 and is in the TensorFlow model format. Arduino could not use the TF-Lite model directly, so a convert script was written with reference to the TensorFlow format, which could convert a TF-Lite into C-source file, which is the arrays, and also detect the TF-Lite input and output dimensions to check for errors. The main code is shown here. And then I downloaded the .cc file and copied its contents to the example program, present detection experiment. Camera and Arduino is connected as the picture. So let's see how it works. We can see both of these 2 times test got the correct result. And here, the biggest difficulty I encountered in the research process was Arduino transplantation. In fact, the transplantation could not be completed directly by copying and pasting the array, and the operator of the main program need to be modified. I modified the optimization operators of the program according to my own model architecture, and I also use softmax instead of logistic. to gain a better result. Secondly, more attention should to the problem of dimension of input and output. According to the original simple program, received input size is 96 multiple 96 grayscale image. Of course, in fact, can be changed to RGB mode, but due to the memory, I choose to keep the grayscale image. Training the model input parameters need to be consistent with it, otherwise it will run failed. I had also been struggling with the invoke failed for a long time. And the size of the model should also be paid attention to. After many tests, it is considered appropriate that the length of the model array should be below 700,000 as far as possible, and that the application memory of the main program should be also adjusted to 180 multiple 1024 as shown here. So lastly is the output and the result part. We can see from the picture, the timing automatic photography time is also set. In the loop function, the 5-second timing photography recognition is realized, and the recognition results are output from the serial port. In addition, the RGB light changes color according to the result. When wearing the mask, the light is green. When not wearing the mask, it is red. Let's see the video here. That's all for my presentation. Thanks for listening.